Alright, so this is part 2 of 5.7, composing trig functions and inverse trig functions. Alright, so remember some things that that are key here. First, there are domain restrictions on the trig functions that make possible the corresponding inverse functions. Number B, recall trig functions of acute angles can be defined on a right triangle. Trig functions, letter C, trig functions can also be defined with x, y, and r. Okay. And so let's look at the examples. All right, so the first one, cosine inverse of cosine 4 pi over 3. So we know cosine 4 pi over 3. Let's draw a little unit circle just so we can see 4 pi over 3. So that's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. About right there. So the cosine is negative 1/2 and the sine is negative root 3 over 2. Yeah? Alright, so the cosine of 4 pi over 3 then is negative 1/2. So this is cosine inverse of negative 1/2. Okay? Alright, so now remember cosine inverse though gives us an answer from 0 to pi. Right? And you'll notice this is cosine inverse of 1/2. So that's 1/2 right there. Cosine inverse means that angle up there. Yeah? Which will be 2 pi over 3. So cosine inverse of negative 1/2 is 2 pi over 3. So notice, works a little bit different. This is cosine inverse of cosine. That means the composition of two functions, which usually the input, when you do use the composition, is the output, right? That means f of f inverse of x equals x, or f inverse of f of x equals x. Not here, right? It's an x value that has the same cosine, but it's not the same x value. All right, let's try letter C. Sine of tangent inverse 12 over 5. Oh, that's a good one, right? Okay, so tangent inverse of 12 over 5 that means there's a theta that has tangent 12 over 5. Yeah? So that means the sine is positive and cosine is positive. So that means it's an acute angle. So we can think of it as an acute angle. And so we can build a little right triangle and say this is theta over here, okay? And if it has tangent 12 over 5, that means opposite over our adjacent is 12 over 5, right? And then we're looking for the sine. So tangent inverse 12 over 5, that means theta would look like so. This over here, we use the Pythagorean. 5 squared is 25, 12 squared is 144. We add the 2, that's 169, so this is 13. Yeah? Okay. And the sine of theta then, notice this is theta, right? This is the sine of theta, and that's our theta. And sine of theta is opposite over hypotenuse. Okay? Remember again, tangent inverse means some value of theta that has tangent 12 over 5, right? Okay, so there's our theta, right? Notice we drew a theta. We didn't use a calculator or anything like that. All right. Number 2, write an algebraic expression for tangent of sine inverse of x over x squared plus 9. This one we will do the same way as I just did that one. So that's a hint that we have. Okay, so we'll do that the same way as that. Yeah, or very similar. All right, and then we'll be able to work it. And part 5, so we'll do number 2 in class and all the others over here in class. And then we'll also leave this one for class. So this one we just need to draw a picture and we'll do that in class, okay? So, and we'll be able to work it once we have a picture. All right, so that'll be part 2 of section 5.7.